Hi students, in this video we're going to look at some geometric proofs, this time involving similarity. So after watching this video, you should be able to know, recall and apply the 4 tests for the similarity of triangles. They're like the tests for congruency with a couple of small differences. Calculate the scale factor between two similar triangles, and then also use the similarity of triangles to calculate unknown values. Alright students, for this video you'll have to recall our definition of similarity, which just means things have the same shape, just different size. You'll also have to remember how to carry out a geometric proof. Alright students, so going over our 4 tests for similarity, they do look a bit like our congruency tests, but instead of sides being equal, our sides need to have the same common ratio between corresponding sides. So for example, looking at our SSS rule for similarity, looking at our corresponding sides, we've got 6 and 4, so let's find the ratio there. 6 over 4 is 1.5, then 3 and 2, 3 over 2 also equals 1.5, and you guessed it, 4.5 over 3 also equals 1.5. So the scale factor, our ratio there, is the same for all of our corresponding sides, so our shapes are indeed similar. Right? This scale factor just means that this red shape is 1.5 times larger than our blue shape in terms of its side lengths. And so that's how we use a SSS test for similarity. Similarly, you can see for our second set of triangles, again our corresponding sides have the same ratio. It's still 1.5. And this time the included angle, the angle in between our known sides, is equal as well. So similar to our SAS rule test for congruency, but once again the corresponding sides have the same ratio, they're not exactly the same. Alright, this third one is a little bit different. Any two angles that are equal mean that our triangles are similar. Not congruent, they're similar. Now, you might ask why? Why is it only 2 angles that have to be the same? Well, for a triangle, remember that third angle, along with the other 2, make the angles that up to 180. So if you've got 2 angles that are the same in both, that leftover angle, that leftover part of 180 degrees, should be the same in both as well. So for the angle rule, you only need to show 2 angles are equal in order to prove similarity. Finally, RHS, once again, we've got our right angle and our hypotenuse has the same ratio. Once again, it's 1.5, and our sides have the same ratio, 1.5. And so those again are our tests for similarity. Alright, let's do a proof of similarity. Let's prove these triangles are similar. So we're required to prove that triangle ABC is similar to triangle DEF. Alright, let's go about doing that. We'll get our tables organized here. And then we can start putting our statements in. So the first thing we can say is that our angles are equal. Angle ACB is equal to angle DFE. And how do we know? Well, we were given that information. So we can say we were given that angle. And there's our first line done. Now the second line, the second thing we can say is looking at EF up this way, which is 12, and BC, those sides look like they correspond. Their ratio is 2. Once again, that information was given because we were given the sides. Thirdly, looking at the other 2 sides we were given, DF, which is 10, and AC look like they correspond. So if we find the ratio of those sides, 10 over 5, that also equals 2. And that's given. So looking at our triangles, we've got our 2 sides that have the same ratio from 2 and 3. The angle included is the same. So we can say now that those triangles quite confidently are similar. And the rule we've got is SAS. Our sides have a common ratio. They're both 2. And our angle in between is the same. And we're using lines 1, 2, and 3 for that reasoning there. And that's as simple as a similarity proof can be. Alright students, so what we have to do in this situation now is, looking at the diagram below, we have to first of all establish similarity. So show that the triangle GHJ here is similar to the triangle GIK. So we'll establish similarity, prove similarity. Then once we've proven similarity, we can then use that fact to calculate this unknown value of x here. So we're going to give that a go, starting in order. First thing we have to do is write our required to prove statement. So for part A, we're required to prove that triangle GHJ and triangle GIK are similar. So we'll get our table going. Now the first thing we can say is, noticing that our lines here are parallel, so JH and KI, they're both parallel. That means that this angle GJH and angle GKI, those angles must be the same size. Right? Same size angles there. Now the reason we can make that statement is, remember, going back to your geometry rules and your parallel lines, those angles we say correspond. So corresponding angles between parallel lines are equal. Now that's the first step, showing that those two angles are equal. We call that the F rule, if you want to just call it that. But there's our reason for saying that GJH and GKI are both the same size. Now the other thing we can say is, looking at this angle up here, right, that angle is JGH, but also that angle is the same as KGI. So those angles are the same. Now the reason we give for that is because they are common angles, or it's a common angle, because it's exactly the same in both situations, right? JGH is the same angle as KGI, because those lines just overlap like that. So we've got two angles, and that's enough to prove similarity. So our triangles GHJ and GIK, they're similar. Our reason is A, two angles are the same, so the third angle is the same, and we can call that from lines 1 and 2. So there's our first thing that we've proven true. Now the second thing we have to do is calculate the value of x. Now let's write a scale factor statement for that. So we can say that Ki, looking at this side and this side, which correspond, Ki over JH should equal GK, this long side, over GJ. Now Ki is 6 centimeters, H is 2 centimeters, GK, now this one's a little bit tricky. GK is x plus 1.5, and then 1.5 on the bottom there. So GK is 1.5, this start bit, plus the x value, whereas GJ is just 1.5. Now, rearranging that equation, we've got 3 equals x plus 1.5 over 1.5, times both sides by 1.5. 4.5 equals x plus 1.5, x equals 3 centimeters. And there's how we can use our similarity to calculate an unknown value. Alright students, so after watching this video, you should be able to recall the 4 tests for similarity, calculate scale factor, and use similar triangles to calculate unknown values.